I'm stoked to come up here and talk. The Patriots aren't playing today, right? Because you guys aren't all going to like disappear at some point? No? All right. So I'm going to give you a little talk, and then I'm going to show you an example about why I started there. So I don't know if any of you are members of this group. I've changed the name to protect the innocent. But we got this question. Internet of Things. I saw it in my email. Can anyone guide me to a simple and generic IoT framework or stack? I'm sure all of you probably think you could answer this question right off the top of your head, of course, because it's whatever you use every day. But this is hot. Like, this is on fire. 17 days, we've had 117 comments on a LinkedIn group, right? This isn't Facebook. This is a LinkedIn group. People like this, right? People like this. And they're talking about it. And there is, if you go scroll down on this, there is a wall of text that will make your head spin. And so I'm sitting there looking at it and thinking, well, I don't know what the answer is to that. But in short, this entire thing, and I have been waiting since Keynote came out to have a legitimate reason to use that. Transition. So, typical in the world in which we live, where we've got data scientists and we're programmers and developers and engineers, our goal at first was to let's figure it out, right? And so somebody, probably a future project manager, came and said, well, I'm going to create a list of the links and we're going to talk about them. And here are 41 frameworks that will do the IoT, right? And I'm going to say the IoT from now on, right? 41 frameworks will do the IoT. Admittedly, some of the taglines are very generic. Shocking that marketing material on the homepage of a website would be generic enough to entice just about anyone to thinking that it was the best thing ever. But you'll see on here everything from hardware, that's an IoT framework, ThingWorx, which is like huge, monolith, an operating system that runs on devices. You see special connectivity methods, probably 3 or 4 RF protocols. You see things that are, essentially data brokers, versions of operating systems, like Ubuntu's got a version. Is that an IoT stack? What is an IoT stack? Why are so many people who actually care about the IoT or what they think is the IoT really trying to standardize, to put all this together and to make sense of it? And it really is, it's human nature, right? And it kind of reminds me, today when I look at all these people and they think of what IoT is, I'm going to play a video here because it reminds me of as a guy who came from a startup, this is it. And hopefully there'll be sound.
The Internet of Things is coming. All your appliances, your tools, your vehicles, they're going to be talking to each other.
Really?
Oh yeah. Your washing machine will tell you if you're out of detergent. And like your can opener, it's going to be talking to your light bulbs.
Why would I want my can opener to talk to my light bulbs?
Because it could save lives, Sarah. Anyway, if you want to see like the future, check out this new smart fridge that I just bought for the office. Look at this baby.
It looks like a regular fridge.
It does, doesn't it? But doesn't actually keep anything cool. I got too many apps running on it, but that's why I bought this smart fan. It's a smart fan. It's a fan that talks to your toothpaste tube and your kitty litter. Okay.
I don't understand.
Well, okay, so you have like a 2-foot. Hold on, sorry. Smart fridge is calling me. Hi.
All right, I'm going to pause it there because it gets really awkward after that. Like I was uncomfortable watching it, but I encourage you all to watch it later. So people talk about the Internet of Things. It's the new buzz. I mean, we all talked about, what was it, Web 2.0, which I thought Web 2.0 was like real-time web, but apparently O'Reilly says it's social media, right? We all talked about big data. We all talked about agile development, and we all, as an industry, people who build stuff, usually engineers, and then the people who are above engineers, who are the leaders in that crowd, the business leaders, wanted to go and classify these things. And we have conferences, and we put labels on conferences, and we all go to these conferences because it is in our nature to classify things that we don't understand well in hopes to better understand them, right? So when people talk about the Internet of Things, everyone starts putting bits and pieces in boxes as to what they think it is. Some guys think it's their refrigerator. Some people think it's an operating system. Some people think it's a layer of communication between devices. Everyone wants to classify what is the Internet of Things, and here's the problem with it. And here's why we do that. It's because we were taught to do this in school. You didn't go to school to learn. Most of us went to school and we had one period and another period and another period and another period. You went to college and you had algebra and computer science and calculus, right? And you also had English. We're taught as human beings to classify things that we don't understand or huge concepts that are hard for us to grasp because they're new. And so that's why we did it. So school was a big influence. Another huge influence on why we want to classify things is culture, right? How many times have you, I'm sure there's enough young people here that know that their first job, and we have interns in the office that do this. They come over and ask me a question, and I look at them, and then they realize that they should have just Googled that, right? It's very obvious. You ask the internet, it gives you the answer, because for most things that most people do every day is a solved problem. It's understood, right? If they don't have the answer, somebody else does, and it's out there on the interwebs, and Google's organizing all that stuff. And so I'm talking about Google and open source and all kinds of stuff at Microsoft, so I kind of feel bad. Sorry. But no, that's it. I did not have time to regex that to like Bing, or I would have. But this is, here we are. We're conditioned to do it, right? That's why this guy asked the question, what's the IoT stack? Because in his mind, you solve things with stacks, right? I've got a problem, I'll apply the stack to it. Last week I was applying the lamp stack. This week I'll apply the mean stack, and we'll solve the problem. It's how we do it. And that comes from not only that, but from business, right? How many MBAs do we have in the room? Right? This is what you want to do, right? Software is a factory. It is a business. We might as well be making cogs. There is a process. You take the business needs, you analyze it, you put it in the blueprint, and you apply the engineers to the problem, and we get product out the end. And it doesn't matter if you're selling cloud services, if you're selling widgets, if you're selling little bunnies that I plug into my computer that make them appear on the screen, and the software that drives them. That's what you do. That's how we apply that problem. So if there's the new thing, it was pretty easy for us to go, I guess, from the dysphoria we had when we started building web pages, right? Anybody built like a web page with like CGI and like C? Like my first web page was in Perl, right? Remember that? Remember those days, right? Good times. I remember buying a book that had the lamp stack in it because people started just to go together on that. And you had your .NET stuff and you had your lamp stack stuff, and that was the stack because we understood the problem when we started building it. And we could do a factory, right? How many LAMP pages and how many .NET pages did we have once people understood the software stack? Cranked them out. But that's a whole way of thinking that turns the people who actually understand the domain enough to innovate and to build new things, it turns them, the engineers, the guys who are on the ground doing stuff, it turns them into these guys, right? That's SALT, right? Do I have to say SALT mine? That's what they do. They come in to work every day, and I see this, and it's really a tragedy for a lot of the folks that I know who end up going and working for a company that treats the software development process, or the innovation process, I should say, right? The research and development process as the salt mine, right? That is a problem, and that's kind of what I'm here to provide a cautionary tale about, you might say. And so all these influences, because we've got the people who are running the businesses who want to say, well, we do tech, we should do IoT, right? And I've fed into this. I was interviewed at Interconnect last year, and I said, because I thought people kind of got it, that if you don't have an IoT strategy, that like your company is going to get disrupted, probably by a competitor who does, right? And then so I guess a lot of business leaders went and decided to say, we need IoT. And so that feeds into the machine of we need a stack, because stacks help us classify the domain. It helps us define, there's a piece that does a database, there's a piece that renders web pages, there's a piece that stores my network connections and does my load balancing, and that's it. That's my stack. I do it. And it's done and it's easy. And I could build 15 like pieces of software for 15 similar problems based on the application of that stack. So we're searching for one, and we have a query out there from someone who is trying to get into IoT, whatever it is, whatever all the buzz is and whatever people are talking about, and the answer of the internet and the answer of the people in the industry who are trying to be or actually are thought leaders is that we have a bunch of links of all things that are IoT, and they're darn near impossible to classify. I mean, I forgot to mention it, but at the end of the last night when I was checking that, at like 3 o'clock in the morning, I saw a post that somebody's making a database of the links in that thread to classify what is there, because that's how we've been trained to think about this problem, and that's because this is easy. This is what we do, right? We're taught to go to grade school and go to high school and go to college, right? We're taught to have revision one of a product, get to your MVP and get it out the door, and then we're going to iterate, and we're going to iterate, and we're going to iterate, and we're going to get that train started, and it's going to go down the track, and it's going to be great, right? That works. I mean, in the open source world, when you have something that is stackifiable, right? Stackable, whatever the word is, you can do this. You can make baby steps. You can make incremental improvements. And we all come to work every day, and we work 8 hours, and then we go home, and we come back, and at the end of a week, we've hit some goals, and we all feel real good about it, because that's it. But you can't do that with IoT, because what IoT really, really is not this. IoT is this, right? This is going to be my IoT vision rant, right? Start rant. Is anybody unfamiliar with this film and what this signifies? Right? If you keep looking for stacks and you keep trying to present the capability that what IoT really is a capability, and put it into a stack like we've been doing for years, you're going to be the one monkey that doesn't pick something up. Don't be that monkey, right? Never before in the history of computer science have we had the ability to take what we can do as engineers, the fact that we can take our ideas and thoughts and innovation and put that in silicon, in electrical impulses, in a program somewhere, and build a piece of software that people can look at, right? That's what most people do with your software. They look at it, or they notice its effect on some other system that they look at, right? What IoT means is that bounds that we've been having since the ENIAC is suddenly gone for everyone, not just the Department of Defense, not just the companies that can afford the high-speed real-time processing and network capabilities. For us, you could go get on your laptops right now and order, for the cost of a third of my laptop, you could instrument this entire room in just about any single way that you wanted, to the point where you could probably put controllers on the doors to open and close them, and turn the HVAC on if you had the connectivity of that, to turn all these projectors on, all from your laptop or from a device that you could put your own intelligence upon and affect physical change in the real world. This is the moment, right? Where it goes from, I've got the best operating system, and I've got the best operating system, and I've got the best BI software, to the best BI software, to the best database. All those things live in silicon. All those things live in the cloud. All those things might live on your laptops, right? But they don't have an effect outside of the people who use the software tools. Now you can have an effect on the real world, and anyone can do it for any problem. When we look at stuff and we go out and talk to people and talk to companies, there is so much potential for the engineers, the software developers, the subject matter experts for whatever area that they're looking at, to be able to affect a change. We're talking saving lives, saving the planet, are the kind of projects that we see people working on, right? More efficient use of energy, helping first responders, helping people get out of cities and areas in an emergency, being able to affect efficiencies in those operations at a scale henceforth unheard of, because things are cheap and easy, and the logic that we can put in it can run in the cloud really fast, and we can affect that. We are the people who would bother to come to this very session, the people who have the know-how and the desire to apply their engineering talent and their vision and their subject matter expertise to a problem that has a real-world effect, right? That's the future. If we do this wrong, and we could do this, and there are some people who are trying to do this very wrong. If we do this wrong, we will have squandered one of the greatest opportunities, probably since the beginning of the computer, right? That's what we care about. Because if you do this wrong, people die, right? Think about, I mean, I just did a big security talk, so I'm already kind of paranoid. It'll be a couple days until I go down on that. But it's Think about if all of a sudden we all have smart meters at our house and all of a sudden somebody hacks those smart meters in a distributed way, right? You don't have to hack the power company. If you hack the end devices on the power company, you can disrupt the power system. Do you know what happens in a city when it's out of power for over 24 hours? Hopefully you will never have to see that because it's not pretty, right? A city that doesn't have the resources to get transportation into those areas, it's not a good thing. We have such an opportunity and such a responsibility to do this right in a way that is open and transparent and basically meritocratic in that since we all can do it, right? We all can instrument the physical world. The cost of doing so is so low. And we all have the technology now to apply to it to turn our idea, our subject matter expertise into some physical change. We have the responsibility to do it right and to harness that power and to build something great. So when I hear people say, well, I need an RF stack, or I need a Bluetooth stack, or I need a IoT operating system, no. Like, stop. It's not a solved domain. It's not a web page. Everyone knows what a web page, everyone knew what a web page was and what a web page did before there was the LAMP stack, right? Everyone kind of knew that it had data and it got displayed on a page and people did some stuff, right? Everyone knew, like when people were originally building application development toolkits, right? Everyone knew you needed like a compiler and a builder and things like that, and they put it together, and that was a solved problem. What does the Internet of Things do, right? If you saw the Internet of Things, would you recognize it? Would you be able to take a look at all the solutions in the world that people might categorize as Internet of Things and identify the ones that are IoT and aren't IoT and put them in a box? So stop, right? That's my thing. Stop trying to classify it. Stop treating it like it's big data, right? Like an evolution of database capabilities. Stop treating it like it's going from the LAMP stack to the mean stack, right? Stop, because we're missing the boat then, right? You're the guy in the back of the cave that doesn't know he's in the cave, right? You've got the opportunity to change the world with what we do, and it's not stackable right now. So stop. And so that's been my mantra to developers, and I get this a little bit. I get this fairly often. You get guys who want to hack stuff. It's usually the device guys, the hardware guys, who have no inhibitions, right? When you go to like a maker, anybody here like member of a maker's guild, go to like a makerspace? It's where you get a bunch of guys with like beards that make their own beer and they 3D print stuff, and they have like an Arduino strapped to the wall everywhere. Those guys have no inhibitions. Software engineers who have been doing it too long, like some of them do. We need to not. So that's my mantra, is that stop thinking about trying to do IoT. Start thinking about the capability that you have, learning about the capabilities that exist in the world today, and how you can take your subject matter expertise about the way that things should be and apply it and make it so. Because you can, right? If it's the physical world, you can make it do what you want. You have the God's eye view, right? And it could be as simple as when I walk in the building, I want the serendipity that I dream about every day. Like everyone has that dream, like you see it in TVs, they do the cutaway to the musical, and the guy's like walking in the office and his friend says hi and there's music playing and everyone's singing and the doors are all open and the birds are singing and all that kind of stuff. You can make that happen, right? But you could do it for your office building, you could do it for your day, you could also do it for food. You could also do it for energy. You could also do it for public safety. You could also do it for the operational capability of your business or your company, depending on what that is. Because there's a tremendous amount of challenges that are coming in the next 50 years. I challenge you all to read the UN reports on food scarcity, that they've done studies about the capability to grow throughout the world. If that doesn't make you as an engineer want to do agriculture smarter and apply your logic to it, then you probably don't care about your kids or your kids' kids, right? Because they're going to be out of food in 2050 if we don't start doing agriculture smarter and taking better care of the planet, right? And we can do that as software engineers. And so don't be the guy who stays the monkey, right? Embrace the new capability that existed that we've never seen before and go out there and get it, right? So that's my rant about IoT and my observations from a while ago and to this very last harrowing 17 days following that thread on LinkedIn. And so now you probably all came here because it was a workshop. So let's build stuff. we're going to use 1 million protocols. I'm going to introduce you to a new software stack. No, I'm kidding. No, I sat there and thought to myself, well, why can't I just do something to show that we're still so in exploration stage, and to use a bunch of different protocols just to show that, like, we as engineers who are moving from silicon to the physical world, right, need to understand these protocols, need to understand the security capabilities and their vulnerabilities, and we need to apply that intelligently. Because it's not like you're writing code to sit in your data center anymore, right? Or even your private cloud, right? Your code and your architecture and your capability lives in meat space, as they like to call it, right? It lives in meat space where people live. So you have to assume that any code that you write that lives in meat space, somebody's going to dump and reverse engineer. Right? That's a whole other level of problems. If it goes over RF, as someone who had signal intelligence in their job title and used to teach radio theory at the National Cryptologic School, that is a vulnerability of non-trivial scale that developers and software engineers today almost never deal with, right? There's so much exploitation that could happen here that doesn't, that people are extremely lucky. My computer could be completely owned right now, probably, because I'm wirelessly broadcasting through that wicked pink bunny that they plugged into my computer, this thing. So we'll talk about that and all the different technologies. But this is just an idea. I could throw some code in the screen, or we could take questions and talk about monoliths. I'm open to both. How many people came here to like see code and Intel Edison's bouncing around and like things happening like that? You guys want to see some of that, like Bluetooth iBeacons and things magically happening on desks? We could do that, and I will leave time because I wasn't everybody to talk about other stuff at the end. How much time do I have left? Oh, perfect. So I want to do this quick. This is a prototype that we, for like a demo, for a big enterprise thing, for a big company that's a real company that knows they need IoT, but at least is smart enough to say to themselves, I don't need an IoT solution. They don't need a stack. They need a capability that they can then build a solution against. So we're playing around with some stuff for them. What I'm basically going to show is, and we don't have to do all, we'll probably just get through the first part of it. Intel Edison's. What that is, for those of you who are not familiar, it's this thing. It's about this big. Intel makes these. It is more badass than the computer than you had 10 years ago by a significant amount, right? It runs Linux. It has dual 500 megahertz cores. It runs Wi-Fi. It runs Bluetooth low energy, right? And it's this big. And I can stack these little things on the back of it, like ad infinitum, with analog and digital inputs and outputs, right? Which I can do to things. We have one of these in our office that waters our plants because we always forget to do that, right? And it's brilliant, and we learned a very valuable lesson that software engineers wouldn't normally think of, is that if you buy a cheap $5 soil moisture sensor and plug it into a plant, after 3 weeks it'll corrode. And considering it's measuring resistance, it looks like your soil is dry. So you, as a developer, are used to this accurate metering or accurate responses from the code that you interface with. All of a sudden, the soil moisture sensor says, hey, the soil's dry, even though it is very, very wet because no electricity is flowing through the corrosion, and your pump starts running for like 10 minutes. And we're in the middle of a meeting, and I'm sitting there, and I'm like, hold on. The plants were leaking because the thing just decided one day that it didn't want to let electrons go through anymore. So this is just it's one of my favorite toys to hack on. If you want something that's going to run forever, you have to learn as a software engineer now. You have to learn a little bit more electrical engineering. You're going to learn that probably this is not the right thing if you want to run forever. You're going to have to write your code at a lower level language, which will be a whole new stack. No, it won't. Right? This is a solved problem. You can do this. I've taken guys who that work for me that have never written C before professionally, and you get them excited enough with little toys, and they start asking me questions about pointers and references. So it's very, very cool. So I'm going to take one of these guys. I'm going to turn it into an iBeacon. So what is an iBeacon? There's a limitation that I realized I kind of stumbled upon in frustration over the last week, why they made iBeacons. Because if you look at a traditional Bluetooth peripheral, right? So like your keyboard, your wireless headset, and things like that, right? They only allow one connection. Because it wouldn't make sense for your keyboard to be connected to two computers, right? It wouldn't make sense to that. So I just assumed that when they came out with Bluetooth low energy, that considering it's mostly for data passing, they would have changed that. They didn't. So I was trying to code it to do that, but it wouldn't do that. So now I've coded it to be an iBeacon. And an iBeacon is just a little Bluetooth thing that's like a beacon that says, hey, this is my ID, maybe my major, my minor, right? Here's my info, and then somebody else who's looking at that iBeacon can measure their signal strength to that iBeacon and know that they're generally close to it, because Bluetooth doesn't go that far, right? Bluetooth is great, and it's great for marketing stuff, for the folks who are designing marketing things, right? Because you know when somebody's from their smartphone, how far away they are from the thing. If they've got this happened to my wife a couple weeks ago. We walked into Kohl's, and she got an ad on her phone, like for the department that she was standing in. And so after the shock and concern for data privacy wore off, I explained to her that, oh, wow, very impressive. They have iBeacons all over the store. So I pull out my Bluetooth sniffer, and it's true. There's a lot of cool experiences that you can give to people from this kind of technology. I guess their keyboard's down-ish in Stanford right now, so I'll talk about what one of the teams there is working on. They're working on a capability to have these kind of beacons and apps on people's phones who are visually impaired, so that when there is a red light at a crosswalk, I don't know if different cities implement it different ways. I was just in Prague, and they do it with like clicks at the crosswalks in the city where the light's red and the light's green to walk or not walk. They want to do it with tactile sensors for folks that are disabled, so that their phone would realize that the beacon has changed its name to red light, from red light to green light at the corner. So as you approach an intersection, you would be alerted without having to look at it as to whether the light's changing or not. Same thing with like crime stats and a whole bunch of neat city data that they can put into it. Although, I don't know how much the city people like the idea of like, you have an app where the background changes or the buzz changes on your arm based on how many arrests in that neighborhood there have been. So, there are a lot of politicians that would have problems with that, I think. But it's a cool little technology, but it's not it, right? You wouldn't build something that does about the same range, a security system with it, right? You wouldn't build, probably wouldn't automate your industrial system with it, most certainly, right? The way that this thing works is extremely, without getting into a class on radio theory. If you're holding this, right, you get this signal strength right here. If I go like this, it looks like we just got way far apart, right? Real fast, because water and radio waves in this band don't mix, and we're mostly water. So, neat little protocol, and we'll explore a little bit about that. There's going to be a lot of Node code in there. For folks that aren't familiar with Node, it's like JavaScript, but for the back end and interfaces with your operating system. So we'll play with that, and then those guys are going to uplink through WebSockets, which we found that's really fun and cool to play with. It works surprisingly well for IoT devices that have the bandwidth to do it. I'm not saying it's the best option. It's one option, and that we should learn about with Wi-Fi and WebSockets. You should definitely learn about security in WebSockets. I know the guy who wrote the WebSocket protocol, or was one of the co-authors of the original WebSocket protocol, and he built a company that secures WebSockets other than what they get through SSL. If that tells you about the security implications of WebSockets. It's good enough for most people, not good enough for banks. So we'll explore that and learn a little bit about how it works, at least within the Node context. And then we Wi-Fi to LTE to WebSockets back up to that thing that we built. We could show you that kind of stuff, but I'm not here to corporate shill you and show you our tools. I hope that you will go check them out and read a little bit about what we do and tell me what you think of them. But if you don't, I'm cool with that too. Hopefully you take something away. So we'll get to code, and I'll show you guys how this stuff works. The idea that we did, you'll see the storms and devices. People very often want to simulate large geographic data sets, and the people who write large geographic real-time data systems usually write them with simulators all the time. And then you try to apply real-world data to them at scale from like the Internet of Things. It doesn't work real good. So that's why we built this, because we can essentially simulate geolocational data by having ranging data. We take it from 2 dimensions to 1, and kind of show as we move things along how you can do real-time processing with it outside of a traditional GIS system that people built. Totally stoked to see it. So I'm going to plug these bad boys in. So for the engineers in the room, this is all USB. And oh wow, you took one of my USB ports, you techies. We're going to have problems. All right. Actually, you're going to have to pardon my, I'm going to have to get a splitter out ASAP, because I need all of my USBs for this. Has anyone here, just for my own edification, has anyone here raise your hand if you've ever used an Edison before? Ever used one? Raspberry Pi? Right? Oh, love Raspberry Pi. So like Python guys you all are, right? You hate the node. Callbacks, non-blocking, no sleep command. I used to be a Python guy. I started hacking on a Pi. Well, I started hacking on an Arduino, and then I started hacking on a Pi, and I've been continuously playing with stuff since. And one day I'm going to find a splitter that I hid in here. There it is. One thing that you will find, that I find if you guys start playing with devices and make it part of your job or part of your business or part of your hobby, you can never have enough powered USB ports. You can never have enough, I'll say that again, you can never have enough powered USB ports. But go on Amazon, spend 20 bucks, get a thing that's like this big, that's got like 8 or 9 of them, and like 1 amp or 2.4 amp of power through each one. You need it. You absolutely need it. And we're going to get back to plugging stuff in. So when you get one of these bad boys, it's very different than your Pis that you guys have seen or your Arduinos. Once upon a time, way back in the day, and luckily with the government agencies I worked with, I got to see some of this old school hardware still in production use, right? You had a mainframe, right? Remember those? You had a mainframe, and you terminaled into it, right? You had a terminal, you had like a PDP something, and you went into it, and you used, there's a command that lets you, when people had workstations that were big enough, there was a command called screen, right? So what I've done is I've basically made myself I've made that little Edison my computer, or I'm going to switch to the other one, sorry. I've made this little Edison my mainframe, and hopefully it'll power up. If it doesn't, we will know quite quickly because I'll have a big red light blinking at me. Because these small computers don't play nice when they don't have large power supplies. Yep, that's it. All right. I'll reboot. Yeah, I've tried TMOS, but you can't do that with this kind of thing. I guess you could. I've never tried to do multiple ones, because usually what you do with these Edisons is that they've got built-in Wi-Fi, so you screen in, you reset the Wi-Fi to what you want. From a development point of view, I then will, once the SSH is up and running, I'll SSH into it, and then to edit the files on it, like I normally would just VI them, but VI through screen is painful. And you'll find for those of you who are rabid VI users out there, and I hope you all are, but I doubt that that's true. Things like 3DD, it's like deleting more than one line is not implemented. So they're very small computers. Did I mention they're really small? They don't do a lot of things. They want to give you. Here we go. I'm in. So I've got my login, and so this is. I'll put it up here. Hopefully, so you folks can see it. It's a little tiny guy, and he's going to be our storm. And let's check his. Let me get my laptop out, and what I'm going to do is create that bridge that you folks saw in the diagram. So through the magic of this tablet technology, I am going to turn on a hotspot and have Wi-Fi on one side and LTE on the other side, right? Two protocols, good for very different things. LTE networks are really hard to, like 10 times harder to hack than cellular networks, but it's certainly possible, right? So those are all things that you've got to be concerned with. Let's see if we found this. Yes, it's connected. All right, so, and I'm going to release this on GitHub once I can clean it out. So we call this the Edison Mobile. So this is our storm. And I'm going to go mount that code. I'll show you. If you guys don't have this, and I don't know how you do it on not a Unix computer, there's a cool tool. I don't know if you can read it. I'm going to try to make this bigger. It's called SSHFS. Has anyone ever used it? It's awesome, right? Love it. If you have a good connection, it makes everything so much easier. So, because this thing has a little tiny 8 gig hard drive on it, but I don't want to have to go through a terminal window or even an SSH window to get to it. So hopefully once the Wi-Fi wakes up, it takes a second on these things. Sometimes if you initiate more than one connection, it goes a little faster. And we'll go to 11. And you'll see, just so you guys and ladies, that stop saying guys so much. You can see this is a full-blown Unix system. It's got, I don't know if this indicates it, but it's got 2 cores in it. It's got gigaram in it. Is that? It's a non-trivial amount of RAM. So it's got enough that you can actually do stuff, run programs. Another pro tip for these bad boys, I'm going to restart this, is that when you get it, it runs a whole bunch of things because this comes from Intel, and Intel's a big company, and everybody and their brother wants to have a piece of this. So there's a lot of daemons that start up when you start the thing that burn power. Like, do you need an MQTT broker? If you're not using MQTT, don't turn it off, right? If you're not going to attach a Bluetooth headset, turn it off. If you're not going to use their development kit, turn it off, right? If you're not going to use MDNS, because these things will chat like crazy. Like I saw a spike in our local network bandwidth when we put about 10 of these on there. It was because they were all MDNSing each other all the time. It was like DD MDNSing ring of what the hell. And it was to the point that they were throwing so many errors. I'm sorry, this is just going to take a second to boot this guy up. I might have to restart him. It was like basically DDSing the entire network. And so their entire network. And then it was filling the logs. And in their wisdom, in the early days, the images that were provided by Intel for these did not leave a lot of space in the log partition. And so you'd have to reboot the thing because it would basically fill up the entire drive. So there's a whole degree, I guess the whole point of the reason I'm telling these stories is that there's a whole layer of DevOps that we should learn as developers to understand DevOps on devices, which maybe is a new category of things that we can categorize. There's a whole litany of RF protocols that we need to know when we build solutions. Because you have to, when you stop thinking about, I'm a software engineer, and start thinking about, I'm a engineer that happens to know a whole lot about software, but I also want to dabble in stuff in meat space, there's a whole new set of skills you have to learn. And if you're not into it, then you're not going to do well. And I hope you all get into it. All right, this should be much better now. Come on. This is why I wish I was here earlier. Maybe I don't have connectivity outbound? No? Oh, I mean, sorry. Works good from both. All right. Better ping times from Bing, huh? Come on. Oh, I know why this isn't working. Because I got on your Wi-Fi. Am I going to break all of the things, tech people, if I jump on the private network? Tech people in the back? Well, if you're watching the live stream and the live stream disappears, then I apologize, but I need to jump on my iPad. That's why. Yep. There we go. Sorry for the delay, folks. We're going to zip through this fun code in just a second. This is a workshop. I certainly want to ask, has anybody here ever done iBeacon stuff at all? Anybody hacked on iBeacons? Cool, this is new. I have never actually coded one until last week. Right along on the journey, like the IoT, where there's no plan and there's no definition, for certain bits of technology that could fit in IoT in any one of a number of ways, it's a really solved problem. or at least a very, very well-known problem, so that we can figure it out pretty easily. So let's the storm code. I wasn't kidding when I said we're going to do this in VI. All right, so this is a Node program. It's like your JavaScripts that you've all written on web pages, because I'm sure everyone's done that. Is this? Do you need bigger? Do we need bigger? I'll go big. Keep on doing that because I've got this thing on. All right, so just like your import in just about every other programming language, or from whatever import, we're importing stuff at the top. Bunyan is what we use for our logging. Normally, logging is designed in Node, is still at base, like logging in a web page. So you console log things, and that's really not good if you're writing code that runs on something that you actually care about log levels and stuff. What my company does, our Node library, OS stuff, utility stuff. Exec is like subprocess, spawn, or spawn many, popen, all that kind of stuff. Just let you hit the OS stuff, or execute stuff. And the Blino is the library that we use to implement either a peripheral, right? So like you implements like a keyboard that we can talk to each other, or it implements you can implement a central with it, or an iBeacon, using the underlying stuff. So this one we're going to implement just a peripheral. We're going to call it Storm. So we're just basically going to use that as, hey, I'm a big bit of badness, right? And we want our other guy's going to go listen to how close he is to the big bit of badness. And this guy is just going to say, hey, I'm alive, and I'm creating a signal. So how you do this stuff, I know it's cool that you guys haven't done this. I recommend playing with Node. It works well for a lot of things. You'll see things that you would have to do in other languages where you'd have to fork or wait. I don't have to do that. But that also means I have to be very, very careful, because I could create loops that are ugly and do bad things. So we 12-factor this, so all of our data is in the environment. We gave our, put some global variables up there. We want our local IP address. I'm kind of using that just so I can make sure that things are connected. Every iBeacon has a UUID. It's like its own unique identifier. I made one up. I think this is straight out of the example. Debug some stuff. Telling you that we're creating a flowthings.io account. I haven't, and I really won't give you any of the corporate stuff, because I think we should talk about more important things. But just think that we have a problem or we have a solution that basically lets you take in a whole bunch of data at scale, thousands of events a second, apply your logic in JavaScript to do stuff with it, and then spit it back out at hundreds and thousands of events per second over multiple protocols to multiple things in IP space, right? That's what we do. So we have a library for Node because it works great on web pages and it works great on devices that can run Node. And that's what we're going to do here. We're just going to create a tunnel and talk to stuff. This is how you call back stuff in Node. The first thing you have to do with these guys every time you start it up is unblock Bluetooth, because by default Bluetooth is blocked, which is probably a good security thing. That like any random user space program, if it doesn't know to execute this command with root permission, it can't just access the Bluetooth module. Cool. And so we unblock it with a couple of fancy command lines. These are the actual commands you run. And for those of you who haven't done this kind of programming, you're saying execute this command, and then when you're done, do this. And because that is a blocking command in Linux, in computer science, that blocks, we tell the kernel to go off and do something, and eventually will tell us it's done. Node just goes on to the next bit of code. So here it'll go through this and say, okay, when it's done, I'm going to call this function up here. Meanwhile, it'll actually go right down to this line and start doing this stuff. Or actually, that's another event handler. It'll actually start going here and doing stuff. But we're getting ahead of ourselves. So we say, when you're done, obviously bail if it's a total error. You execute the second command about a couple seconds later, because unfortunately, despite the fact that whatever kernel they're using for this, whatever it tells you, hey, Bluetooth is it's unblocked and we're good to go, it doesn't automatically come up instantaneously. The interfaces take a second or two. So we're pausing a second or two. We're going to come up, bring the interface back up. If anybody, raise your hand if you have a question and give me a line number, and we'll talk about what's going on. And then this is Blino. So like for you as a software engineer who doesn't know anything about perhaps how Bluetooth works, it's really simple if you get evented systems. It's already done. You're just telling it, on the state change event, which will fire as soon as the thing fires up. If we're powered on, start advertising with that UUID and throw an error if we don't, right? So that's how simple it is as a developer to control the hardware. There's lots of people who are doing that already. So you really just have to stand on the shoulders of what they've done. Set the local address we can use as a unique identifier. And otherwise, obviously, if it's not powered on, then we should stop trying to advertise on it, right? It's never going to work. We also will go through and start the WebSocket connection. So this is why I think WebSockets are cool, and there's a couple other bidirectional protocols that are in use today. There's a lot of people who are building old school M2M stuff that still runs on TCP connections, right? You're a Modbus, which is like come out of the M2M world, or the M2M is trying to be on the internet world. WebSockets is kind of same problem space, trying to solve in a different way, where you've got, I want a bidirectional communication, I want it evented, I want my device to do stuff when it gets told things, and I want it to tell something else things, and that's it. It's a good, reliable thing. And the reason that you use it for, especially for constrained devices, is that it takes much less overhead than using a REST interface, right? Because if you think about, if you guys remember back to your networking classes, right? If you think about what the steps are for a TCP handshake, how many packets do we have to send? Right? Before I even you're the server. Before I talk, I gotta send you. You gotta right? You gotta synac me. I gotta ack you. Right? There's a whole 14-step involved handshake, right? And then we can start talking. Here, you do that once, and then you're just talking. You don't have to do it every time you want to do something. So whether it be WebSockets or just a TCP thing, or whether it be a proprietary tunnel or another protocol, this is a common thing, right, that you'll find when you're instrumenting the real world. Go for it. Mm-hmm. They're actually all going to, so the cars are going to sense, so they're using Bluetooth. So this program actually starts up the guy who's saying, I'm the storm, right? He actually doesn't talk to any of the other devices over Bluetooth. He can coordinate with them through the cloud, through the FlowThings.io, because he's just got a one tunnel to FlowThings.io and trust that somewhere in the cloud we're going to put the logic in place to send that guy command when he needs it. It's when you scale out, you can't have everything talking to everything. Mm. Yep. Yeah. Well, they're sensing each other. They're just sensing their environment. They're actually not connecting. If we implemented this as a peripheral, if the storm was followed the programming paradigm and capability kind of framework of a Bluetooth peripheral, then what would happen is that one car would have to actually connect to it, and Bluetooth low energy has the same problem that regular Bluetooth peripherals have, is that when you start a connection, nobody else can connect to it. So you'd have to connect to it, get a range reading, disconnect from it, connect to it. Hopefully the other guy is going to have to coordinate with it. No, right? That's too hard. That's why Apple came up with iBeacon, right? That's why it's there. It's because this idea of when I just really want to know that I'm around you with some kind of radio presence, right? Some kind of RF presence. I don't want to have to connect to you like your keyboard or speakers or a Bluetooth headset. Yeah, total unidirectional. This thing is going to send out energy that just says, it's basically broadcasting, so the frequency hopping type thing, right? Saying, hey, here's my UUID. And then the other guy's going to say, well, how well do I read that? It can broadcast its transmission power, which is something that kind of an RF and electrical engineer will give you the guidelines for saying that, well, this antenna with this much power, I'm telling people that my transmit power is this, so that then they could do some math and infer, because based on what your antenna specs are and my antenna specs are, in theory, I could tell about how far away we are. But I mean, anybody who's hooked up a Pringle scan to a Wi-Fi scanner knows that signal strength is directly proportional to things like gain, right? And so every bit of hardware is different, and the RF environment is vastly different. So it's a good approximation. It's never going to be you can tell when you're 6 inches and a foot away, but you're never going to be able to tell whether you're 6 inches or 6.5 inches away, unless you're in an RF isolated chamber and you know all the antenna specifications of everything. So, yeah, any other questions about the Bluetooth stuff? No, so here, WebSockets, we're just saying when we open it, we're going to connect. And when we're done, we shout about it. And just every once in a while, we're going to create a drop in flow things. A drop is an event. Get it? Flows. Flows are like streams of events. Drops in a flow. It's a very beautiful analogy that I've looked at for a long time. And we'll go and handle response from WebSockets, and we'll put that out there. But you'll notice everything is callback based. And I see this more and more because we can't predict the real world. We can't put it on a timer, right? You need to be constantly scanning. Most of your application that's living in meat space is going to have to constantly be aware of its environment, and then either doing stuff itself or reporting back to someone else to do stuff. And when Central comes calling, you have to immediately know that I've got a message here and it's got to do something. That's why MQTT was big, like when IoT started off, and it still is pretty darn big, because it's a great protocol for that kind of low bandwidth. We're talking to each other over a message broker, right? Positives and negatives for all these, but we like WebSockets. We could do MQTT as well. So let's fire it up. Let's see what happens. Let's hope that my code works. So if we fire this up, oh no, what happened? Oh, I know why. You guys get to see some VI. So this is just, if you guys aren't doing this, I'm just going to throw it out there as a shout out. Does anyone not know what 12-factor, their 12-factoring their code is? Not familiar with it, 12-factoring? It's the idea of that, there's a 12-factor manifesto, you should read it. The idea is just generally that my app code and my app logic should run with an input from the environment and not be dependent on the environment. So have you ever worked with an application or a program that you guys wrote that has 3 configuration files? Perhaps big projects have multiple configuration files. Maybe they're in XML. Maybe they're it's somewhere else. There are properties files in places, and you're bringing them in and then running it, right? So DevOps guys have to go then take that and write a template to then to change those values depending on the environment. It's a whole big ugly mess of ugly that we've been doing the wrong way for a while. So finally these guys came up with the 12-factor manifesto, which is that there's an environment file. In Unix it's real easy. You've got your environment. Get my environment file that basically exports every variable I need, and then run it. So then my app, if I say it runs on my laptop, when I send it to the cloud or I send it to the big data center, right? All I need is someone needs to declare in the environment in which it's running these things. Whether it's a Unix environment or a Windows environment or a whatever environment, these variables need to be available to when it starts, and that's it. This is what leads to the Docker, right? We've all heard about the Docker, right? Has anybody, the Docker is awesome, right? I don't use it in production, but I sure as heck play with it a lot. And I think one day the tooling will get good enough that we can use it in production. But it's very cool. You should use it. It leads to this ability for you to write once and deploy somewhere and scale automatically. So it's very, very cool. I know I rewrote that, right? Yep. I might have to run this twice. Sometimes it really takes a minute for HCI1 to come up. And I did. That's fine. Oh, yep, that's why. So run it again, and it'll come up. Hey! So, this guy is now telling the world that he is as a device, he's online, and that he's a storm, and that anybody else is going to coordinate through flowthings.io, because you're going to see when we fire up the car is going to phone home to flowthings.io and say, hey, what storms have you seen lately, right? So it's what storms have you seen in the last 10 minutes? And if you've seen them, then I'm going to start scanning for them. Because if I turn this scanner on in a room with all of these Macs and all of your smartphones, it would, at least on the car simulator, it would be like a wall of text. It would be a constant wall of everyone's device sitting there doing things. So I'm going to switch us over to our next device, which will be our simulated car. I guess we can move it close to the other one, I suppose. We might move the storm and not the car. right, so hopefully now this guy will boot up with enough power that I can talk to him. Again, I'm going to use my trusty tool screen. It's not that guy. I think it's that guy. Yep, he's booting. So this all should look familiar to anybody who's used Unix. It's booting up. We'll just stay inside this guy's environment. Look good, right? Yay, and unblocked. Nope. Oh, that might be. Did I not update this one? That's why. Oh no, it's only the storm stuff. All right. One more time. Not that. If that didn't come up, then it's clearly because I did not commit the code last night. I clearly did not commit the code last night. But we're going to walk through it right here in old school mode. If I could make the screen green, I would. So, same stuff. We bring up our IP interfaces. Here what we're doing is we're telling our device from the central kind of place, the internet, right? The flowthings.io, where all your other things are interfacing in real time. We're telling this guy, hey, look for these other storms, right? He's going to query it, and then he's going to subscribe to a stream of storm updates. That's why we have these global objects, because we use that whole idea. If you want to have a unique list of things, then it's nice to sometimes put them in a map and have the key be the thing that you want, and so you just overwrite the old data every time. And then Noble is the library that lets us be a central, so like a computer in the Bluetooth world. So we start our logging, we start our debugging, we start things, we unblock Bluetooth. Here we're going to do a little pro move and say, once we've got that unlocked, I want you to start another function that has another callback, right? So when we start up our code, we're basically saying, hey, go do this flow thing setup, which is another function that has another couple bits of blocking in it. So we're basically firing off everything that's blocking early in the program, right? So that it can coordinate coming back. And so we're doing as many things in parallel as we possibly can. So we're firing off this blocking things in the flow thing setup, which runs the same way as the other one. But then we're also going to say set timeout, which is a fancy way of saying wait 3 seconds and then run this function. So we run this function, we bring up our interface. HCI is just like host controller interface, which folks like basically it looks and operates just like Ethernet address, right? Whether it be a Wi-Fi 1 or a Bluetooth 1. And so here we configure our Noble service, which is our Noble, as I like to call it. Noble is the central service, and so it acts like your computer might act if it's connecting to a different peripheral. We're telling it again, it's fully evented, so we're saying when you start scanning, tell us. When you stop scanning, also tell us. When you have a state change between powered on and powered off, start scanning, and this is the pro move right here. Start scanning. Don't look for anything in particular, right? That's what the 2 blocks are. Don't look for anything in particular, and true, allow duplicates. So what that tells the kernel to do is, well, basically just hooks right into the bus, the dbus. This is the kernel bus that's getting all of the Bluetooth driver, because it'll basically broadcast all the time every time it sees something, right? So it's constantly scanning the network, and so you're constantly getting results. It's not connecting, because when you connect, you stop scanning. So it's scanning constantly. So this code will actually, if I were to run this and just leave it kind of without any filters on it, I could sit there and report to the web. I could walk around with this thing attached to my laptop and have it WebSocket up everybody's MAC address and everything that's happening in this room with this little tiny thing, right? And I would know all of the names of your devices. I probably would know their hardware addresses. I probably know what factory they came out of, and all kinds of interesting things. Much power comes much responsibility. You can do very cool stuff with that. There is a lot of very cool public safety stuff that's coming down the line that has to do with sensing people because everyone's got a smartphone. It's like everyone has. People are going to start recognizing you by the MAC address on your Bluetooth interface. I promise you. Not on the street, but in their big data system, they're definitely going to recognize you by that. So it's a great potential to do things like from managing traffic to managing pedestrian traffic, walking across streets and intersections and having lights be on longer when there are more people waiting on the corner to cross the street. To evacuating cities is one of the best things that could happen if you have ever lived in a tsunami area or lived in a place where there is a high degree of danger where there may be evacuation drills, right? Imagine being a cop trying to organize an evacuation drill and being able to see how many people are on each road in real time, right? Because everyone's got a smartphone and everyone's smartphone's on. And if you put something like this around here that can sense your smartphones, right? We can start counting you and knowing how many people are in a great place. With great power comes great responsibility. I'm a big fan of the Constitution. I rose my right hand to preserve, protect, and defend it for 9 years. I did that. The potential for Fourth Amendment abuse in this technology is non-trivial. So if you are also a fan of the Constitution and rights, we should definitely, my pitch there is make sure that you understand it and make sure that people who are understanding it or who are implementing it understand it and make sure that there are safeguards in legislation as we move forward, whether it be educating the people who have the capability to abuse that power in the first place, which frankly many of them are not educated as to what they're doing, and making sure that the city that goes and installs those Bluetooth sensors, right, holds the heels of the company who implements it in the fire to make sure that it can't be hacked or exploited by foreign governments or our own government if they were to be able to use and have free access to that system. So huge challenges coming down the pike. Again, great power, great responsibility. Thank you, Spider-Man. So here's the magic, right? So we use, for those unfamiliar with the JavaScript, you've got a storm address and it's got a known property. So that's a way of saying, because in JavaScript, an object is like a map, right? And so because functions and things are the same. So we're just saying if you've got an address and if you basically have this key, right? But it's actually an object and it's called a property. Semantics, right? It's just basically saying that does this hash have this key? If it's in there, then we're going to go put it in the measurements hash for that address, and we're going to push the RSSI. The RSSI is a signal strength indicator, and the reason that we're pushing a whole bunch of those is that if we reported it every single time, it would flood the cloud and have no value, right? Or at least very little value. You don't need to tell the cloud, the app, the little dashboard we're going to look at. You don't need to tell it every 1/10 of a second what the strength is between two nodes. You probably should tell it once every second if you want it to look real-time-ish. So what we do is a little bit of fog computing. Anybody heard of the fog? Has it been a topic here yet at IoT Day or at Boston Day? So the fog is the edge of the cloud. I'm not kidding. I'm not making this up. This is a term. I first heard it at the Internet of Things World Forum in July of last year. Fog computing is when you pre-process data to go to the cloud from the edge. And so here we're doing fog computing. We're going to average that list of readings we get every second so we can send it up. You've seen fog computing. You are one of the few people who have said that I've seen fog computing and I understand what it is now, right? It's basically doing a little pre-processing at the edge so we don't flood the cloud with data that is useless, right? Because most of the IoT stuff we're going to send to the cloud and do something with anyway, but it's still going to be irrelevant in 90 seconds. So we've got these updates and we're sending stuff out there. Connection callbacks, all of that stuff. What did it not like that I did earlier? Oh, that's why. I don't need that anymore. All right. Cross your fingers, folks. Hey! We got it. So this is really useful. You're seeing basically an average of what the signal strength is from the guy up here to the guy that's still sitting down here. if you wanted to see it on the internets, you could go to this fancy, only number 3 is running. But you can see, I'm far away. I'm gonna put my hand in front of it, right? I'm gonna be meet in between these two things. Even though I'm moving closer now, I bring them closer. Whoa, whoa. Red alert will, well, remember we're averaging these, so it takes a second. When you get them really close, and it's fascinating, depending on the orientation of the antennas, we're trying to figure out the polarization of them. Like as you twist these things around, you can see pretty quickly, oh, they're practically touching. Oh my, right? So there, you've seen it done now. We don't have enough time to go into too much more detail and still leave questions. But that's just an example of things that literally have. We have a Bluetooth protocol, right? We have a little RF happening over here. They're also connected via Wi-Fi. That's also going over WebSockets. It's also going to the cloud. That also, when it got read, that sent other events and used other cloud databases to do things that are interesting with that data. But this is just an example of the kind of, I guess, pushing the edge. If you've been working on the LAMP stack, working on the mean stack, you've been working on your business intelligence tools, building plugins to hook up your database and your whatever your data business intelligence schema to this kind of stuff. This is way different, right? This is way different, right? You don't have to worry about RF usually. You don't have to worry about network connectivity and how your application will work in poor network conditions, other than people who build cell phone stuff, right? That was a baby step, I think, when we went from real mobile app development to cloud development, right? Because we had a similar environment. It was just a smaller computer and a couple extra things. IoT is the big step. This is the monolith moment. We have the power to instrument and understand and affect change in the real world at our will. It took me, when I had this thing figured out and sent data to the cloud, to integrate with another cloud database and fold it all back through this stuff, it took me like 3 minutes, right? Just I type in some BS data, right? You can do that today, just like I did it with, through Bluemix with Cloudin and through, I think, one other service, and then back through our service and back in. You can do that today with just about any database that's out there, any service that's out there. You can compose them all, right, in real time. There's no excuse because compute is not going to get more expensive. Network is not going to get more expensive. Hardware is not going to get more expensive. It's only going to get easier, and right now it's trivial. It's inexcusable that we are not teaching IoT, that software developers are not becoming electrical engineers, right? It should be a requirement in college today to understand how this stuff works, because those are the people who are going to be able to take data from meat space and turn it into something awesome and affect change, right? So that's my general thesis. That's my story. Morning glory. And if you would like to come up and see this stuff, I'm more than open to letting you guys handle the Edisons and the small computers. But with the 8 minutes that we have left, I would like to leave it open for questions, discussion, anything like that. Hey, thank you. Appreciate it. I will be around for 8 minutes, and then I am heading to the Amtrak. So if you want to get a hold of me, if you think of something later that you want to, and the reason I have to head home is that 1 year wedding anniversary today. So my wife would not be pleased if I wasn't home at the end of the workday. 2, I'm an Eagles fan, and today's Dallas. So like if I am not back at my apartment by at least the end of the first quarter, I would feel like a really bad Eagles fan from the jump. So super cheap. Depends on where you're getting them. Again, that's me. If you have questions, concerns. So the bare job here right here, this thing is you're looking at $40 bucks now, depending on where you get them and how many you get. But it comes with this connector that you can see back here, and I have one I think I can take apart in my bag that I can show you. That it's connected to is called a base block. It's made by a company called SparkFun, which makes a lot of easy to use, shockingly fun things for IoT if you're that kind of guy, like me, that thinks it's fun. Here, I'll pull one apart. This is my backup. This is it. Here, I'll pass this back. Share it with your friends. But this is all of it. It's got this 70-pin connector, and you can go nuts. And that ceramic thing on the top is the Wi-Fi. So that's how they're cheap. They're $30. You can get them a lot cheaper if you get more. Then you have to build the things around it. These little blocks give me like the terminal capability. They give me a charging capability. They basically treat the internal hard drive as an external hard drive, so it looks like you plugged in an external hard drive if you plug the second cable in. But that's cheap. It's overkill. It's actually really bad for things that you want to leave out. Don't tell until this. I said this. It's bad for things that you're not going to plug into a wall, right? It's really bad for things that you're not going to. It takes way too much power. It's way better than a Raspberry Pi, but it still takes too much power for something you're going to not plug into a wall. But if you're prototyping something, it's so forgiving. It's like you're running it like in a small instance on Amazon, right? It's super, super forgiving. But at the same time, you've got the capability to have input and output through one of a half a dozen protocols that are commonly used for IoT things that are external, and through just general GPIO for the folks that have been on their Raspberry Pi. There's a ton of GPIO ports, and you can buy an IDC or an ADC. This company makes these little blocks that you can stack, so they're made to stack. So when we build stuff, they actually have usually it's sticking out of here is a GPIO connector, so you've got a bunch of those, and then an analog to digital sensor on the other side. So if we want to take measurements, and it's better than you get in Arduino. It's like 12 or 14-bit resolution over variable voltage ranges. So it's they're great, they're fun, but they're not the only thing, and there's blowing up.
I'm going to do a quick interview. So do you have to leave right now?
I have to be at South Station at 1 o'clock.
Oh, yeah, loads of time.
I don't know. Well, I had to my time slot was supposed to be now, but I was told I was not allowed to have my time slot. It was full. But I totally will do an interview.
Lunch. Do you want to take one more question? We'll do
Yeah, I'll take as many questions. Go for it. What was that slide? JFGI? It is on the interwebs. Boom. There's a data sheet. So, yeah, it's pretty awesome. It has 1 gig of memory, 2 cores, and they're coming out with newer ones. They're even better. The other thing that's really awesome is it'll do the 5 gig band, which is kind of cool. And you can buy that with a full-blown, make it look like an Arduino, or a little tiny breakout. But we have a breakout that's that little SparkFun one I like better. But yeah, it's common, it's available, and there's analogs. You've got, if you want something that runs on much less power but has Wi-Fi capability, look at the Photon. We just got those in our lab because we were supporting folks in a hackathon that were building stuff with, and using C. Get to and from the cloud or other systems all around you. No Bluetooth or anything, but you run it on a 9-volt for a non-trivial amount of time.
Take one more question.
No. Oh no, shoot. I like talking to people who like IoT, right? Just remember the monolith. On us, our generation, to make it good. So, any other questions? Go for it. Mm-hmm. Hackathons are the best thing to do it. We've done, they happen in Dumbo all the time, down in Brooklyn. They happen around here all the time. I just came from one in Stanford. So Stanford's got hackathons. Come on now, right? You guys in Boston have no excuse to not be going to them, because they do. I know they do have money. I know the people who run the IoT group meetups around here. You're going to find that, and the other people who you're going to find that are local experts are, like I said, like the bearded, weird, smelly guys that make their own beer at the makerspace, right? Because they've been doing the IoT, but they've been doing it like for art. Like, do you know, there's a lot of people who are really good at IoT today because they're artists and they've done installations, right? Because how do you orchestrate? And I'm not how many art fans there are out there, but if you go to a modern art installation, very often there are things that are happening with motors and lights and projections, right? And that's all a micro network. And there are things. It's not like it's not as easy like as the guys who like we're going to instrument our factory with 1,800 PLCs that all have the exact same API and all operate the exact same way. An artist says I want to make some things, and that's going to be my art. And the orchestration around that, a lot of people people that you wouldn't expect, go to wherever they've got like your local MakerBot lab that you can go there, and find people who do installation art. Because they generally, there's a whole language that's kind of like processing that they use. There's a couple really neat web stuff that has been used in that industry for a while that's now coming into the cloud to kind of coordinate the actions of a whole bunch of things in an easy way without somebody having to have a CS degree to do it. Because shockingly, most modern people who do modern art in the installation format don't have degrees in computer science. All right, anything else? I will not keep you from sustenance. So, well, thank you again for your attention, and enjoy your lunch.